Choosing the right robot, Chapter 4. Choosing the right robot for your mission is crucial. The success, safety, and efficiency of your operation depend heavily on matching the robot's capabilities to the specific challenges of your environment and task. In this video, we'll guide you through key factors to consider to make the best choice. Before choosing a robot, it's essential to clearly define your mission requirements. Start by identifying the primary objective. Is the robot meant for inspection, transport, mapping, or search and rescue? Each goal requires different capabilities. Next, evaluate the operating environment in detail. Is the robot going indoors, such as in an office space with people, furniture, and narrow hallways, or outdoors on uneven terrain, open fields, or staircases? Will it need to handle slippery floors, carpet, or gravel? These details directly influence what kind of mobility system and sensors the robot will need. Then, consider the type of mapping and navigation. Do you need 2D or 3D mapping? Will the robot navigate autonomously or follow preset paths? If it's navigating around obstacles or people, real-time mapping and obstacle avoidance become crucial. Battery life is another important factor. How long does the robot need to operate continuously? A short demonstration robot may only need 30 minutes, while a patrol robot might require several hours or swappable batteries. Don't forget environmental conditions. Will the robot face extreme heat, cold, dust, or rain? These factors determine what levels of environmental sealing or ruggedization are needed. Finally, clarify any practical constraints. Are you working within a strict timeline or budget? Are there size or weight restrictions? Taking the time to define these factors early will guide your decisions and help you choose a robot that's optimized for your mission, efficiently and effectively. When choosing a robot, matching its mobility to the terrain is critical. Wheeled robots are efficient and fast on flat, smooth surfaces like indoor floors or paved areas. However, they struggle with uneven or unstable ground. That's where tracked robots shine. They offer greater traction and stability on rough terrain, sand, gravel, or grass. If your mission involves navigating stairs, rubble, or tight spaces, quadruped robots are ideal. Their legged movement allows them to step over obstacles and maintain balance in dynamic environments. And for tasks that require an aerial perspective or access to hard-to-reach locations, drones are the best option, flying above ground-level challenges to deliver mapping, surveillance, or inspection capabilities. Always choose mobility based on the environment the robot will face. When selecting a robot, it's critical to consider what it needs to carry and what it needs to sense during its mission. Let's start with payload capacity. If the robot needs to transport tools, sensors, or collected samples, exceeding its rated payload can seriously affect performance. This is especially true for quadruped robots, where overloading has immediate consequences. They can lose balance and collapse. Their joints may overheat, shutting down the system. They move significantly slower under load. And of course, battery life drops sharply due to the increased power demand. So it's essential to know the exact weight of all mounted equipment, especially if multiple payloads are involved. Now consider the sensor suite. The sensors you choose should match your mission goals. Cameras for visual monitoring and inspection, LiDAR for mapping and navigation, gas detectors for hazardous environments, thermal imaging for heat signatures in rescue missions. For navigation or mapping, LiDAR and an IMU are generally required. An IMU, Inertial Measurement Unit, is a sensor module that measures a device's movement and orientation using a combination of accelerometers, gyroscopes, and sometimes magnetometers. Most LiDAR units come with a built-in 6-axis IMU, which is sufficient for many applications. However, if your algorithm or mission requires 9-axis data, you'll need to add an external IMU to capture the additional orientation and magnetic information. Finally, make sure the robot is physically and electronically capable of handling the sensors and payloads you need. This includes mounting, power supply, and data integration. Selecting the right combination of payload and sensors ensures your robot can perform its mission effectively, safely, and without damaging itself in the process. When planning your mission, power and endurance are key factors that directly impact your robot's performance. Ask yourself, how long does the robot need to operate without stopping? When planning your mission, power and endurance are key factors that directly impact your robot's performance. Ask yourself, how long does the robot need to operate without stopping? Some missions only last an hour, while others may stretch over a full day or more. Battery life varies widely across platforms, and high power sensors or heavy payloads can drain energy faster. Be sure to consider the robot's total power consumption, not just its movement. Look for models that offer extended battery life, quick swap battery options, or on-site charging solutions. A robot that runs out of power mid-mission can delay critical operations. Selecting a system with the right endurance ensures continuous performance and reduces the risk of mission failure. Another key decision when selecting a robot is determining how much autonomy it needs. Let's start with the basics. Manual control is ideal for straightforward operations or environments that require real-time human judgment, such as navigating unpredictable terrain or handling delicate interactions. The robot is entirely operated by a human, usually via joystick, remote, or keyboard interface. Semi-autonomous robots take things a step further. They can perform specific functions on their own, like following a target, avoiding obstacles, or patrolling a predefined path, but still require human supervision for more complex decisions. In some cases, voice commands or input triggers may guide the robot. This is especially helpful when the robot is within communication range, but still benefits from shared control between human and machine. Now, in communication-limited environments, where there's no network, no tether, and no real-time monitoring, things get trickier. You won't know what the robot is doing in real time. In these cases, the robot must operate with scripted or fully autonomous behavior. For example, if you've created a SLAM map and uploaded it to the robot, it can autonomously navigate between predefined waypoints, such as going to specific locations to capture images or collect data, repeating this mission without external input. Finally, fully autonomous systems are designed for repetitive, hazardous, or remote tasks where human presence isn't safe or efficient. These robots can plan, act, and adapt with minimal input, relying on advanced AI, localization, and sensor fusion. Choosing the right level of autonomy ensures your robot has the correct software stack, sensor suite, and decision-making logic for the mission. The right balance also improves efficiency, reduces operator workload, and enables consistent results even in challenging environments. Robots don't just need to function, they need to survive and operate reliably in the environments they're placed in. Before deployment, carefully evaluate the environmental conditions your robot will face. Will it operate in the rain, in dusty construction zones, or in extreme temperatures, either sub-zero cold or intense heat? Exposure to water, dust, vibration, and temperature swings can quickly damage not just the robot's electronics and actuators, but also its sensor systems. Cameras, LiDAR, IMUs, and other delicate instruments are often exposed, so they may require their own waterproofing, impact protection, or enclosures. That's why it's critical to check for key environmental protection specifications like ingress protection, IP, ratings for dust and water resistance, shock and vibration tolerance for mobile and rugged operations, operating temperature range suitable for your mission area, and ruggedized, sealed designs for both the robot and its onboard sensors. Investing in proper environmental durability from the start ensures your robot stays functional, safe, and dependable, even in challenging conditions. It reduces the risk of breakdowns, mission delays, or costly damage to sensitive equipment when it matters most. When selecting the right robot, you need more than just a product. You need a process. Let's walk through a 10-step checklist to help you make an informed, mission-ready decision. Define your mission objectives. Start by clearly identifying your mission goal. Is it for inspection, mapping, delivery, or rescue? What specific tasks should the robot perform? And what does success look like for your mission? Assess the operating environment. Next, examine where the robot will operate. Is it indoor or outdoor? What terrain will it face? Flat, rocky, or stairs? Will it encounter obstacles, tight spaces, or harsh weather like dust or rain? Determine mobility needs. Mobility should match the environment. Will wheels work, or is tracked movement needed for rough terrain? Do you need a quadruped to climb over rubble, or a drone for aerial tasks? Payload and sensor requirements. What does the robot need to carry? Does it need to mount cameras, LiDAR, or gas sensors? Make sure your chosen platform can support and power those systems. Power and endurance. How long should the robot operate before needing a recharge? Can you swap batteries or recharge on-site? Also consider power draw from sensors and payloads. It adds up. Control and autonomy level. Will the robot be manually operated, semi-autonomous, or fully autonomous? Define how much independence it needs and how far it should communicate reliably. Environmental durability. Does the robot need waterproofing, dust protection, or shock resistance? Can it operate in high or low temperatures? These specs are critical for field conditions. Budget and maintenance considerations. Know your budget, not just for purchase, but also for upkeep. Will the robot require regular maintenance? Will your team need training? Additional considerations. Think about size, weight, and portability. Check for compliance with safety or regulatory standards. And if you're integrating with existing systems, make sure there's compatibility. Now, shortlist robots that meet your needs. Compare their strengths, weaknesses, and total cost of ownership. Choose the one that offers the best balance between mission performance, cost, and reliability. For the full checklist, check out the PDF at the link displayed on your screen. Choosing the right robot isn't just about specs, it's about mission success. And remember, Norsat is here to help. From mission planning to final selection, we support you every step of the way.